Okay. All right.
Yeah. Oh, it's showing me issue sharing the screen. Oh, okay. I see.
Okay.
Okay. Can you see the PowerPoint?
Mm-hmm.
Okay. Yeah, Simon, feel free to like let me know if I'm going too fast or something. And then I'll take it slow. Okay, so we are today, as Simon said, I'll talk about constructing tomorrow's reality today. And that is what we kind of do. We kind of build the project on digital model before it's actually built. And there are different software, there are different ways to do that. And that's what we'll go over. So I know I graduated in like last year May, and I had a lot of guest lectures at NJIT, and I know how it gets. Sometimes I'm just trying to make it like really interesting and cool, and not so much boring. So wait. Okay. Yeah, so we'll talk about digital twin. That's like a new upcoming word. Then there's BIM, which is building information modeling. That's like a very important tool in digital twin. And if you've heard about, is there anyone who has actually heard about BIM or like VDC term in general? I don't know how familiar are students with the term BIM.
They learn Revit as
Yeah.
part of BIM.
Yeah, Revit is a tool to make a BIM model.
Yeah.
BIM is basically like a model, and there are different ways to get to the model, different ways to access the model and use it. And of course, we'll go over some of the technology and construction, some real world examples, and why we need this technology in construction. And there's AI, of course, just like any other industry, AI has taken over construction as well. There are a lot of new softwares, interesting softwares and users that's coming in these days. And some of the opportunities for students in the BIM VDC world, and how it's beneficial for students actually compared to anyone else. And yeah, and just and then just go over some fun uses of BIM and digital twin. But okay, so let me tell a little bit about myself. So I did Bachelor's of Science in Architecture from NJIT. I graduated last May. Uh, I actually started with Bachelor's of Architecture, which is a 5-year program. And about 2 years in, I kind of got interested in construction and technology, especially in construction, just like exploring new ways to figure out to how to enhance the process of building a building. And that's what made me kind of switch to Business of Science in Architecture, which is like a shorter course, but you can explore more options such as structure and construction. I did some internships at NJIT, nothing major one. Actually, my first real internship was with Simon at Active Design Group. I started part-time and then I went on doing full-time. Then I interned for a little bit at an architectural company. It was just mainly drafting and doing all those little bit stuff. And then I got chance to come to Dallas and work for One Construction. So my actually position is VDC coordinator, but VDC is a brand new term that's being used in construction industry, which actually means virtual design and construction. So I usually prefer to add BIM to it just so people know more about it. BIM is like the more familiar term in construction world. And there is slight difference between BIM and VDC, and why there's a difference. I'll kind of go over it. Yeah, so as I said, I work for One Construction. We are mainly based in Texas. We have about 5 offices over here and about 1,200 people, which is kind of a medium range firm in terms of construction firms. Some construction firms are like really big, about like 15,000 people. So we are quite small compared to them. We mainly do more of hospitals and school buildings. By school buildings, we do anything that they need. That is, even if it's as simple as making a residential hall to making like a lab for them. Labs are usually extremely complex. So that's the range that we aim for. And there is no really budget that we aim for when we're building a building. We build from about uh, a 2 or 3 million project to about a 5 billion project that we have right now. And I'll go over some of them and kind of show what is my role and my role in this project, and how as a BIM and as a VDC coordinator, we can speed up the process and get more accuracy. So this is one of the project that currently we are working on. It's in Fort Worth. Fort Worth is like a part of Dallas. I just wanted to be more accurate. It's about 80,000 square feet, and it's a psychiatric emergency center. It's just 2 levels, but it's extremely complex structure because there is not that much space in the building, and but the owner wants a lot of things going inside it, and especially if it's a psychiatric building, so there are a lot of rules that apply to it. We'll actually go a little bit of the inside of this building and see why it is so complex. Another one is this Cook's Children Medical. This is again in Fort Worth. You can see it's kind of a smaller project. It's 37,000 square foot, but uh, this is actually like an experiment project for us and the owners. We are trying to use as many new tools, as many AI tools as possible in this project. Just because it's kind of small, we have option to not get it right the first time and have enough time and money to redo some things if needed. So it's been really interesting working on the project because we have a lot of tools to choose from. Mm. And then this is like another big project that we just launched last week. This project has been in talks for like 2 years now. It's yeah, I mean, if you're reading the figure, it's not really a wrong figure. It is a 5 million square foot project. It's basically these three buildings and the building at the back. So this is a it's named New Pediatric Center, but I hope when it ends, they have a better name for that because this doesn't really make that much sense. So it's actually a hospital and kind of a training area. So if you see few buildings at the bottom right, that's the existing hospital, that's Children's Health Hospital. And on the left side, there are a few buildings that are kind of cut off. That's that's UT Southwestern, which is like a massive school in Texas. I think it's one of the biggest medical school in Texas. So they both kind of joined and built they're planning on building this particular project. It's I would say they are kind of aiming it to finish it by 2032. So there is a long timeline for this project, and a lot of people are working on this project already. It has been in works for like 2 years, as I said. Um, okay, so digital twin. Before we get into any uses or anything, let me go a little bit into the history of it. So the term digital twin is actually credited to Dr. Michael Greaves. I think that's how you say it. In 2002, he started working on it in using it in the aerospace industry, and then it was really quickly brought into manufacturing industry as well. Um, I would say the real use of digital twin in construction started at around 2008. That's in America at least, and then it didn't really pick off instantly. There were like few years where people were still testing and trying it out. It was in last 5 years or last 6 years that people have actually started using a digital twin model and uh, trying to make the best out of it. So it started. It is credited to it is credited to Dr. Michael Greaves, but the initial concept that was of digital twin was actually founded by NASA in 1960s. That's since 1960s they have been using sort of what digital twin is. That is, it's not just making what you see in a computer. It's more about going to the simulations and see different outcomes that are possible. So NASA used to use it for space simulations and and predict like the trajectory if the engine has this much power or it has this much power and all those stuff. That's how it actually started and since decades ago. But in about 2002, that's where like more people got intrigued about it and started using it. So today it's used in a lot of industry, including manufacturing, construction, defense, and in sports as well. A lot of sports team actually are trying to implement digital twin as much as possible. There has been constant development in, as I said, in last 5 years, 5 to 6 years at least. And we try to use as many softwares as possible at one. That's actually kind of my role that comes in. I get to try out different new softwares and kind of recommend to the company, okay, we should use this one instead of this. If there's already a software that's being practiced, then if there, what's the process to change it to a different and a better softwares. That's where my role kind of comes in. Um, so BIM is like, it's like a construction name for digital twin, basically. BIM is uh, it's building information modeling. It's how can I say it? I'm just trying to put it. It's like just building a model. If you have a BIM model, that means you have a digital twin of the existing one. It's not really a process. It's not really an outcome of anything in particular. It's just building a model. Okay, so there are multiple ways to build a model. Of course, it again depends. If you're in structure, you would probably use Tekla. If you're an architect, you would probably use Revit. So there are a lot of softwares. There is also softwares to render all those models that you have. So there's no particular right or wrong tool that you can really use in BIM. It's just whatever works best for you. It can be a combination of two tools. That's what most of the companies actually use. They would probably make it in Revit and render it in something else. And it's, yeah, as I said, it's about combination of the two, combination of softwares instead of using just one software. So you might think this is a building, this is a digital twin as well. Why is this why does this look complex? So if I remove the skin of this building and just see what's going on inside, this is how it looks like. This is a snapshot that I took. You can see the real complexity. It's just two levels, but you cannot really see what's going on. And this is not something that design team always gives. They'll just be like, okay, we want the dug outlet to be over here, and that's it. You figure out the rest. So there are a lot of uh, there are a lot of systems that really go inside a building, especially if it's a hospital building. So this one, there's ducts, there's piping, there's electrical, there's mechanical piping. There, so in such case, when we have less space, but we want a lot of items inside the building, we need to kind of have exact accuracy of where a particular pipe would go. And if I break it down by flow, this is how it would look like. This looks much more visible to me, at least. You can see like there's one big duct that's going. This is just like level one. Then there's like electric pipes going. So another question is, where would all of this go? Who decides if a pipe should go on this side or it should go on the other side? If an electric duct should be below the other one? Who decides all this? And how do we design it? How do we know if there's an issue? So if there's an issue that we are not seeing, and that's where clash detection comes in. So clash detection is basically like, it's bread and butter for us. I do it like, that's like 50% of. Right. Okay, I thought someone was talking, but yeah, that's where clash detection comes in. Actually, it's like, as I said, it's like bread and butter for us. It's 50% of my job. Um, so in such scenarios, when the building is extremely complex, there are ways to speed up the process and trying to get as much as accuracy as possible. So if you see on the right side, that's actually a CUP. That's a central utility plan. Simon, do we use CUPs in New Jersey and New York area, or is it not that much? This is something I learned about when I moved to Texas. I'm not sure if people in New Jersey or New York use it. It's a central utility plan. So it's basically hospitals have it as a backup system if electricity or something goes out, and it can kind of store and produce its own electricity. And I think you're mute, Simon.
Oh, I think probably that's depends on the overall the campus or building complex. I'm not sure that,
Yeah,
but
yeah,
more power plants should be somehow kind of plans based upon maybe their capacity they need. But I think I've been heard like a Colgate campus. I think they do have their central plant and also providing all the their power for their whole building complex.
got it. Yeah, right now in Texas, it is somewhat like if it's about a certain square foot, the hospital is above a certain square foot, they
Mhm.
kind of ask you to have a cup in it, which is like one of the most complicated structure to be built because there's so much of less space and so many things going inside it. So here's another example of why you really need clash detection. So this, so honestly, this is like I was trying to get a good view, and that's why I got a space which has that's why I kind of got a room which has enough space above. But usually there's no space in between, like the pipes, the ducts, everything. It's just like touching the ceiling, and that's when the real complexity like kicks in. So how do you know what's the hierarchy that's being used? So this is like a general hierarchy that's being used. So for example, the one at the bottom is the most which cannot be moved basically. So if you get a model from architecture and structure, you cannot interfere it unless there's no other option. You cannot really move a beam or a column or anything like that. That's just not possible. And then there would be, then if you go one step above the civil would be probably a storm line that's going out of the building. So that's like all government things. It can probably be moved, but it would be a really long process to move it. Then of course there's gravity systems. Gravity system basically is like everything that's coming out of all coming out of the building and all the rooms. So when, for example, when you turn on a sink, uh, the water that's coming in, that's being pumped, but everything that goes out, that's not really being pumped. So that gravity has to do the work for that. So you need to have the exact amount of slopes and all those complexity. So it is given a good priority. Then there's mechanical ducts and pressured pipes. So I would say mechanical ducts are just a little bit more important than pressured pipes just because of the size. Sometimes the ducts can be massive. You can like really walk inside a duct. It can be that big if it's a huge building. So that's why I would say, and it's like hard to move a duct. There are limited amount of turns it can take, and pressured pipes, they're basically you can kind of turn anytime you want. You just have to increase the pressure. Then there's electrical, those are the conduits. And lastly, there's branch lines. Those are usually fire lines, which are not really that important. They're really tiny. So as I said, this is like a standard one. This is kind of what we start off with. But as the scenario changes, a lot of things changes. Like if I was doing a project, probably in electric, if there's a cable tray going, I would actually give it a more priority than mechanical system, just because the electric cable has probably like 10 to 15 conduits going inside it. So instead of moving all those 10 to 15, it might be just easier to move a small duct. So it's like things change as the scenario changes. That's like the key over here, but this is like the base that's being followed in the industry. So this is where clash detection really comes in. This is one of the softwares that we use over here, which is Naviswork. So let's say you have an architectural model and you have a mechanical model that's like duct system and duct pipe. You can kind of select both of them and run a clash between them. So every time they are touching or like going through one another, it would sort of show as an issue. And that's what's happening over here. You can see there's like structure at the top, but the duct is actually going through it. So this would be a big issue. So you can just like call the duct guy and be like, you can show him this, and he'll probably have to move the duct out of the structure because you cannot move a structure. So I don't know if you can see it clearly, but there's at the top, there's like an issue which says like 2600 issues. So this is all pre-building. The building has not even probably started building yet, and they already have these many issues. So that's why you really need a BIM model. So before a building is actually started, you can find out all the possible issues that are going to be there in the building and try to already deal with it. Here's like another one. So these are all the open ones. So you can kind of set status to it. You can add a comment to it. So for this project, there were a lot of issues, but as the time went on, the issues started getting cleared when people started moving the items out of the way for one another. And it's back to 4 issues. So from being at 2,600 something to coming down at 4 issues, that's like massive. You have That's like a massive work. And when you see it in reality, it actually makes a lot of difference when it comes to time, especially. For example, if someone comes with duct and when they try fixing it and they see, oh, it's actually going through a structure, that's a lot of rework. You'll have to go back to the shop drawings, change things, bring in the new duct, and do all those complex things. And but when you have a model like this, it just makes a lot of things easier. So this is kind of the graph McNamee curve that's kind of used for marketing BIM when a company is kind of starting. So what it really shows is, if you see the red dotted line, that you can see how this is where you kind of find out majority of the issues in a building, which is sometimes it's too late to find out issues. That's what it's trying to show. And once you find out issue and it's too late, there's a lot of construction cost that goes into it. That's production cost, that's labor cost, there's time, there's everything that's being wasted. But if you have the issues, which is the red straight line, if you kind of figure out the issues before even the construction starts, you can already start working on the changes that needs to be done. And this does not only impact time and money. So there's this study that shows that about 2.2 billion tons of annual uh, annual waste comes from architecture itself, out of which 30% is rework. So of course you can recycle and reuse some of the items, but there are other ways. That's where BIM comes in. The model can really help you reduce the amount of rework that's being used. Yeah. So um so what is VDC? What's the difference between BIM and VDC? That's virtual design and construction. So as I said, BIM is a model. VDC is more of a process. So it's like you can have a BIM model, but how you make it and how you use it, the entire process, that's BIM. That's VDC. So there are different softwares to do that. So let's say you kind of do a site analysis with uh, Lyra or uh, Dial UX, and then you kind of take it to 3D modeling. That's where you actually produce a BIM model using. It can be using any software. These are just some of the examples. And of course, then you can visualize it. That's rendering. Sometimes if you're just using for construction process, you don't really need that much visualization. It's usually for the owners to see how it's going to be turned out. Then there's for coordination, there's Naviswork that's majorly being used. There is another software by Autodesk, but they kind of bought Naviswork, and now Naviswork is the main software. And then there's Procore that Simon was talking about. Then there's Revesto that's being used. And there are some, we actually don't do much programming, but you can do some of the program in Dynamo and Python that can really help speed up your process. And this is where all these come in, which is like 3D model. 3D model is BIM model. Then there's 4D, that's time. Usually these two are the ones that are actually being used majorly. 5D, 6D, 7D, they're not that much for construction industry as of now. I know in manufacturing, some people use facility management. I'm not sure if it's exactly 7D, but digital twin has also been used in manufacturing for the facility management part of it. So why do you need VDC? So there are a lot of teams working at different times on a project. If a project is, let's say, 5 years, there's a different team that's working in the first 2 years, which would be like design and pre-con. And when it comes actually into building, there will be a complete new set of people using it. So it's kind of hard to communicate everything and transfer everything to the new people. And that's where VDC comes in. That's where the model actually really helps. And that's what we do. We kind of get all the possible data from the structure and the design team and send it to our people on site and kind of help them understand what's actually supposed to be built. uh, so this is like a graph that I personally use. So as I said, VDC is like still upcoming. There's no right or wrong way in VDC, but this is how my company we use it. So we have this one big VDC department. We also handle them completely internal. If it's a, I know at some construction firms, they kind of use they kind of use external sources to make BIM model. Then there's different amount of involvements of different teams. So there's a lot of amount of involvement from the design team and the engineers, owners, not so much, and a little bit from the PM team also. By PM team, I mean the project manager who's looking over the time and the money, and the superintendents, the people who are on the site. So there's different amount of involvement from different people. And this is how a digital twin is supposed to be used. You basically use sensors and database to kind of predict the best outcome possible. So for one example, there's this bridge, Strava Bridge in Norway. This was built not that many years, not too ago. It was like in early 2000s. And suddenly one day they had actually implemented some sensors in the building, and one of the sensors probably turned on and it was showing an issue. And they saw the and this is how it actually used. So you can see on the right side over here, there's like more amount of pressure compared to the rest of the bridge. And they initially thought it's just like a heavy vehicle is probably going over it, but it wasn't really that. I'm not sure what the exact issue was. It was probably just a little bit of construction issue, but at least they kind of figured it out really early before any accident could happen, and they could close down the bridge. So that's where digital twin really comes in. And once they kind of figured out, this was in Norway, and there were like so many other bridges, so they kind of ended up implementing sensors at all the bridges, and now they can track all the data that's coming out of the bridge. So that's what you really use the digital twin for. You can kind of, you learn from the database, and you learn like what if something is about to go bad, you can kind of like stop it. And okay, lastly, let's go over some of the cool technology that we are using. So there are a lot of options nowadays. There's drones, there are 360 cameras, there are just really smart measuring sensors as well. And there are laser scanners. And so this is like well, this image you see on the right, that's actually taken from a drone. So what drone does is it kind of using laser. It also uses sort of laser scan and throws lights, and depending on the speed that it comes back, it kind of uses topography. It uses it to like figure out the topography. So let's talk about some majority of the softwares and the hardware tools that we have right now. They're used for during construction. So let's see what's like the outcome for that. So here is one of the image that comes from drone. So you can see how they kind of scan the building, and now they want to flatten this particular area where the building is actually supposed to be built. Um, on the right side, there's some calculations. So they put like, let's say they put the elevation at 456 over here, if you can see on the right side. So it can kind of tell you what amount of extra soil that you will need. If you already have an extra soil, if you already have extra soil, how many cubic feet do you have, and how you can like, how long will it take you to take it out of the site and put it somewhere else. So as I said, this is all done by drone. This can be done in person as well, but it would probably take you weeks to do that. This, if once you have the drone once you have the drone data, you can just figure it out in like 2 seconds probably. You can just change the number and try to figure out a different cubic volume for it as well. So here's another example. This is again taken from drone, and you can see some reports on the right side. So these are stockpiles. Usually on a site, you cannot have certain amount of stockpiles. You will have to take it out, and you need a lot of trucks to do that. So up until now, what's the usual process is you probably call a guy and you'll be like, okay, we'll probably need 30 trucks to take it out. And it does end up to be around 30, 40. It can go up. It can also increase and decrease. But once you have a drone data, you can see it kind of just like clicks around, click around. You can just click around the stockpile and you can see how many cubic meters it is. And you can just um, use that number to just divide it by the number of trucks you will probably need. And um, yeah, that can be like really useful when it comes to site. So as you know, even the site changes a lot during construction. So here's another analysis which they have used. So just not the floor plan, drones can also figure out elevations. So here what they're actually trying to do is trying to figure out if there are any issues in the elevation, if there are any sort of cracks or anything that's going on. And this is all auto analysis, by the way. This is not like done by a particular person. You can just set the drone, it will go, it will fly, come back and do the analysis by itself. So here it kind of shows like, okay, there's an issue, there's something broken. So it will kind of alert the person on the team like, wait, this particular area, there's something broken, and you'll probably have to go back and check it, but it will at least alert you in some way. So that's the real advantage of using different tools. For post-construction, there are so if you probably live in an old house, you know there are not really floor plans for the old houses. You'll have to go to government and get floor plans and all the things that is going underground the building. But now all the new houses and the new buildings, the owner actually wants how the house is supposed to be looking. Maybe it's for selling. So this is another example that this is done in Matterport. So you can see how you can go around and take entire scan of the house and use it for selling purposes or use it just to show it to someone. So we'll just look at this video over here. You can see the amount of clarity that it has. And this is actually something that even I used when I was moving to Texas. I was in New Jersey. I wanted to tour an apartment and see how it is. And they just sent me this. And it actually made sense. I didn't really have to be in person to see the apartment. And you can see it can just like go over the stairs. It can figure out where the light, it can see the amount of light that's coming in. And it's like once you have this data, you can, that's the real beauty of scanning it, that once you have one scan, you can produce multiple things out of it. You can have a video, you can have a 3D model, you can have rendered images, and you can have a detailed flow plan for it. Another area that's being used is for Notre Dame. We know this, the roof was sort of burned down, but there was one professor from New York who was actually in like early 2000, he was into Gothic structures and he wanted to understand the study of it. So he used different technology to scan the building. Of course, this was in early 2000, so they were not the best softwares out there, but this is how it looks like. And this is what it's actually they're using to restore the building. So it kind of shows you where the beams are running from, how the structure from how the structure is from the inside. And there's this robotic dog, if you might have seen somewhere, it got really famous when it was with Jeff Bezos for some reason. So this one also has multiple users. Oh, I think I skipped a slide. So this is basically a drone image. This is actually what I was working on for a project. We did a building in 2010, and there was something that fell off the building at the roof. And you can see how we are using drone to do that. Drone can not just take images, it can also take thermal captures. So there was an amount of leakage that was in the building. And this, imagine someone going up to a build to roof and looking at it. Instead of that, you can just do it from the drone. It's just like much safer to do, and it's much quicker as well. So here is like, once we had an issue over there, we kind of went around the entire building, and you can see how there are how, although just one of them was actually broken, a lot of them had issues in them. So of course, this is like a 10-year-old project, so that's not really that old in construction world. It is a fairly new project, so they kind of uh, got to know the real issues and started working on it. The building was closed for a amount of time. Yeah. Okay, so let's see the small video of what Spot can do. Okay. So if you saw from the video, it can do multiple things, and we'll go over some of the things that we kind of use it for. It's a really cool thing to use on the side. We are experimenting with different scanners that comes with it. So if you see the yellow part, that's the body for it, and the scanner at the top that keeps changing. You can use different sort of scanners, and that's what we are experimenting with. So what does it actually do? So it's actually meant to be on the site 24/7, and you can really ask anytime for it to like get up and go and scan itself. You don't really have to do anything. You can be in a different state and still use it. Um, so it is used for site documentation, because site changes a lot. Site changes almost every week. There's like a major difference in site, and that's how it's supposed to be, just because you're building something. And that's where this really helps. So what does it do? It actually uses a laser scanning. It actually scans the building with a laser scanner at the top of it, and gives you the data, which can be used for just like tracking the progress of the construction, giving it to the owners. And another thing, as I said, the remote access, that's like the most important part of this is the first completely autonomous um, device out there, I would say. For others, you at least have to be and look around. For this one, if I'm currently in my home and I want to see what's going on the site, I can just ask it to go to this particular spot, and it will come back. It will do that and come back and send me the data. Okay, so artificial intelligence. So as you can see, there are a lot of softwares that's already come into the come into existing. Not all of them are good. Some of them, they are still experimenting and trying to figure out the best way possible. But some of them have really doing a great job, such as like there's OpenSpace, there's Bentley, there's Doxel. Those are like the really famous ones right now that have taken that are being used. So we'll go over Doxel a little bit and how we use it and how it can help really speed up the process of construction and how it can give you more accuracy. So it is automated construction progress tracking. So how it really works is you give it a BIM model, and all you have to do is they have they kind of they use a 360 camera data. And once you have that, you can kind of compare and see the two at the same time. So if you see over here on the right side, the white, that's a BIM model. And on the left side, that's what actually is being built. Of course, it's in progress. It doesn't look exactly like that. On the BIM model is like the final model. So they're kind of on their way to get there. And that's like the key part of this, that you can see the difference. And as I said, a lot of companies and a lot of people work on this. So if there's something that's not right, you can kind of point it out at the same point and they can make the changes if needed. So here's another one. So the one that is a little bit blurry, that's what the scanner gave. And what the one that you see in green, that's what was supposed to be built. So you can see how far apart they are. So this would be a good time to probably call out the electric guy and be like, you didn't really place it where it was supposed to be placed. And in this one, it doesn't look like that big of an issue because there's nothing else that's supposed to be going. But sometimes if it's a tight space, there's probably something else going through it, and that would end up making a lot of changes. And with that, it can also give you an accurate prediction of completed, how much is completed. Like you can see the mechanical duct, it's in red, so it's kind of going behind the time. But if it's green, that means it's on time, or at least ahead of time. And this can be also tracked by the owners. It can be tracked by the people who are on field, who are not who are just sitting in the office. So it can be accessed, and this can be updated on daily purposes. It doesn't have to be like per month or like per week. And if you want a detailed analysis, it can even give you that. For example, just like the fire duct, just like the mechanical duct, that's the one that's behind. The rest of it is completed. So that's how you can use AI in it. So opportunities for students. So BIM market has really grown in, I would say, past 6 years. If you can see, it was about 4,000, and now it's predicted to be about 8,000. So there are a lot of job opportunities that's coming in. One of the reasons it's really good for students is because of the amount of softwares. Not everyone who's working on site, they are like that curious about the softwares or really know about the softwares. It's just the people who are graduating are really aware about the softwares. So that's why they kind of look to hire some new minds who are ready to explore different softwares, because it is a task to like work with all the different software at the same time and trying to figure out what is the best process. So this is sort this is sort of a diagram that my manager actually showed me when we were about to hire someone. So VDC is kind of combination of, there's a little bit of design knowledge that you need, there's coordination, and there's engineering that you need to probably properly work in a VDC area. So when a firm is hiring, what they kind of look for is at least a person has 2 or 3 out of this. So someone who's like me, who's from an architectural world, I know a little bit about coordination and I know a lot about design. And they were sort of like, okay, if you know 2 of them, we can teach you engineering. And like my boss says, he's a civil engineering, so he doesn't know that much about design, but um, and kind of I teach him a little bit about design, and of course he has learned a lot he has learned a lot by himself, just like being on the side. So this is like sort of how VDC department works. And it's not just in US, a lot of countries over the world, they are using BIM model. It's actually being used majorly in UK and UAE. US is a little bit behind right now. Like if you can read it, in UAE, there are all the projects that are above 40 stories, they kind of have it mandatory to use BIM model. So yeah, I think all the projects in UK, UAE, and even Australia, they are using BIM models and VDC in the projects. So apart from construction, it's a major deal in healthcare also. You can see there's this one person who's practicing a surgery just by using a VR. He's not really doing a surgery. So this is like a big deal where you can kind of like visualize things and practice it before doing it in real life. And of course, we talked a little bit about aerospace. Um, they kind of use it to see how uh, they kind of use it to see the wind analysis on the building and which area would have more pressure of wind compared to another one. It's being used in sports as well. If you are like a soccer fan, for me, this is like a new thing that came out a few years ago. They used digital twin for this, and yeah, I'm not sure if I really still like this, because sometimes it's, if a player of the team I'm supporting is offside, I don't really like this technology. Uh, Apart from the it's being used in Formula One racing also. They do a major part in wind analysis as well, and where the wind comes in and goes out and how they can use to speed up the cars. And of course, there's Apple that has recently launched the VR, and um, VR is basically using a digital model and a physical model and a digital model laid over each other, and that's how they use it. Um, yeah, I'm sure you guys have seen a lot of videos on this on TikToks, and yeah, that's what I had.
All right, thank you, Dab. Wow, this is amazing. I think it's a lot of technologies. I think this is great at the perfect time that our student should really take a look at closely. And I'm also, as I practice structural engineering, I like to promote and encourage more and more because the way we worked is really still out of date. I know some degrees we could not replace our personal physical works for built in environments, but you can use those technologies can save a lot of your effort, and you can improve productivities. And I think we need to really survive and catch up both and advance in our structural engineering field. So anybody has any questions? I think our student, actually civils engineering student, they learn Revit. I think that is kind of undergraduate, one of our course. I think I explained Revit to me is a production tool first, right? Then what structural drawing, in order to create the structural drawing, we used to use a 2D AutoCAD, right? This
Yeah,
AutoCAD and new technology is about 30 years old now, 30 years
yeah.
old.
AutoCAD,
Uh,
it's outdated right now. Not many companies use AutoCAD
mm,
anymore.
yeah, but here it depends on. So I mean, I would like to share briefly because I'm practicing in a big company and small company and still, uh, but as a structural engineer, which means I has to work with many different level of architect, right?
Yeah,
So the architect, like a big company like HOK or KPF and SOM, they always the first adapter try to use all new technologies, right? Even these
yeah,
days, they try to explain and implement it adapting the AI like Mid Journey and or Photoshop and something like that during the design competition. They use it and they introduced me. Wow, but small, like a one-man architectural company practice, it depends on project. They still use or 2D AutoCAD or yeah, but minimum is Rhino and sometimes Revit. But it's case by case. There are too many different cases. So it
yeah,
depends on size of building and all the designers, especially architect. But here, here we are mostly try to see what will be the future of our whole effort, and as a big team. So contractor usually has a more big pie, always try to push the bound level. So because they have to deal with all this complexity during the construction,
yeah,
more and more. I think design builds really value this VDC service. I am fully aware of it. And obviously, and design teams also adopt it. They develop some BIM 3D models based upon their contract. But this is the way to go. I think we cannot just, put it behind and you want to learn later. But this is all every industry goes. So all of you, the student has to really fully aware and learn one by one. But obviously, as a strong structure engineer, we have limitations because we're not contractor. So I think your focus mostly structural, the model. So now question is, as you show the first hierarchy, right, pyramid of the priorities, the architect and structure engineer define those structural 3D geometry first.
Yeah.
These days, architect like they they really want something crazy.
Yeah.
More and more that it's hard to understand the geometry and means without understanding 3D geometry, we cannot provide structural form to solution. So I think engineering is not only just calculation, I always push it, is design. We need to really think broadly and this old technology and tools gonna help us. So just I want to encourage you guys to catch up, even though you may have just interest in maybe small, local project, relatively big. But you know what? I think it's only this is positive, and the technology is going to change the world. So I want you to think and learn, one step at a time.
And yeah, as you said,
And
now the owners actually are in contract. Yeah.
yeah, I think the government job, obviously, beam delivery program, I think that is most likely mandatory. Big company, even though small renovation project, like recently I worked with Perkinsville for canopy. They just force us to use a beam because they're gonna use a beam, so they want us to use the Rabbit as a part of beam tool. So it's consistency. So workflow should be like a team works. Is part of also, let's say, language. You want to coordinate, you need to use the same language, right?
Yeah.
So this is something is I'm sure this is must. It take time, but most some of them is a first adapters gonna proceed. There'll be more pioneer and be leading and changing the market. But if you're last adapter, yes, obviously, eventually some degrees you don't have choice. Like for example, Android, no, the analog phone disappeared, right? Now it's a smartphone, digital phone, only last. So think that way. Okay. Anyone has a questions? I think I'm always pushing. He's kind of be one of your contact can talk with you for future maybe kind of positions in the construction company, right? There's a lot of opportunity he just offered, try to share with you as alumni, and this could be another networking and up in the job market uh, opportunities, or he'll be your another good
Yeah. Feel
contact.
free to reach me out on LinkedIn. I'm usually active on LinkedIn. And yeah.
All right, anyone? Are you guys actually awake or cleaning snow, shoveling snow? I hate this online basically. I think I know that I think last two semesters during the COVID, wow, it's really tough.
So what I've been trying to do throughout these reviews is if you go to the back of the reference manual and you pull the exam specs for civil engineering, what I've been doing is I've been going through them one at a time. So topic number one was math, and then topic number two is probability and statistics. Topic number three is computational tools. So really what should be next is ethics. I've decided to hold off on ethics for now for two reasons.
Wait a minute, what is this?
What is this? Ethics, in all honesty, is a topic that doesn't take a lot of time to discuss, so it's something we can put off, and I really don't want to rush through econ. Econ is a very doable section on the exam. The questions are usually pretty straightforward, and And it's something that with a little bit of practice and a little bit of work, it's something that can potentially be a slam dunk. So I want to give econ its day in the spotlight.
Somebody's talking?
Yeah, I think by accident.
Okay. All right. I think Dev, can you maybe put on your slides something that maybe more fits between, I think, design procedure, part of design procedure. What do you think? I know you're in the construction company, so, but have you ever participated in all the design build project and design phase or something? Who initially, based upon your experience, who actually uh, decide that the delivery method or tools? Somebody has to recommend, right? Typically, architect might be the one they recommend the beam. Especially a hospital is very complex. So usually, yeah, this beam is absolutely beneficial.
Yeah, so we kind of work with, so usually when you work for a hospital, there's like, they have a construction department, each hospitals. So for example, if it's like a children's health cancer hospital, they have their internal construction department, about a few people who kind of looks over all the construction project over the country. And they set the standards and they let us know like what are they looking for as built models. So recently, as you said, it has been mainly having BIM models. So up until now, their requirements were just what they want as final product, but now they want to have the procedure as well. So the project, the DocCell software, it's an AI software that I showed. There's this one company who actually put in the contract that we want to see the construction as well, see the construction progress. So they have that in the contract.
All right. I think, okay, here's something that actually remind me. I think, yeah, design, construction, yes, this is great tool. Lastly, the end user, construction, the owner has their facility management team, which is, right, we always talk about three pillars: the design, design technologies, and construction technologies. I think we are talking about. Third one is property technology. After building is built, somebody will just operating it. I know especially the building has a lot of features you need require maintaining. This light bulb, electric duct, machines, all getting old and somehow needs to be replaced. Especially central plants. Based upon my experience a while ago, in New York, is that Columbia or Presbyterian Hospital, New York City Presbyterian Hospital? They had a day on the central plant. They need to install the new generator on top of existing building, but they need to build some additional floor on top of their existing parking garage. But problem is they need to bring their own gas pipe from the opposite side of the building. So they have to install gas pipe, right? Almost a couple of 100 feet. Think that way. All right, this is another example, not new construction, but something somebody has to figure out where we're gonna put the new pipe because existing, you show a lot of stuff, right, inside the building, right? It's impossible to figure out. But I walked through with architect and facility manager. We discussed where this potentially can be installed. So we found some room on the wall, along the wall. We installed the bracket and installed the pipe. So it's kind of trouble, almost 300, 400 feet long. So obviously at the time they didn't have any drawings, right? I think this is good or bad. To me, the old building, the project I worked on, even now, no existing drawing. So the owner typically hire 3D scanning company to scan, and they create some structural architectural plan layout drawing, right? That is the base. The architect is working on new program as well. The structural engineer has some limitation because those are all architectural stuff, not really structural elements. You cannot clearly see it, but still better than nothing. So I think the thing is, from now on, if property owners should have this 3D BIM model, I think during their lifespan and operation, I think it's really beneficial some way. You don't have to rescan or try to figure out at the site, or you don't need to do some too many probe, which is actually save a lot of also effort as well, right? Yeah. As a structural engineer, I always go to the site and try to figure out, but they're all behind us in the curtain, behind the architectural members. And I cannot guess. Some of them I could figure out, but I am to open it, right? But yeah. The thing is, it depends on if this owner already own this building. Yes, we can open it. But if not, I think we need to kind of put some construction drawing and demo drawing and get the approval. And there are a lot of different procedures, which actually somehow a lot of waste. So I think this BIM model, I think is for the future, I think it's really beneficial. As even a structural engineer, I see this benefit, right? And yeah, you show me the drone. Yeah, I don't want to go up to the roof. I mean, a lot of probe. I went up to the roof, even single story building, but sometimes they don't have a stairs. They have a ladder. Sometimes, yeah, most likely I have to climb up on the ladder. And I took a photo, 3D scale, 3D camera, helpful, but I always take my drone. So just kind of videotape, which is pretty fun to videotape though in a building on top of theirs. So I think I want all the students here at least really open your mind, and this is going to be nice open kind of seminar that what you're looking for. This is really current technologies. I think construction industry is going to change the entire practice. So which is good. So I don't expect want you guys to do by manually, physically.
Yeah, and there are a lot of new technologies coming in as well. It's not just limited to what I showed today. There are a lot of new technologies coming out almost every year.
Mm-hmm.
Yeah, of course, everyone.
Yeah. So because how many groups you have? It's only you. I'm sure there are a couple of folks to always review these technologies, and you're gonna get a lot of feedback from the real field operators, and right?
Yeah, because we have like 3 in Dallas. Yeah, we have like 3 people in Dallas, but our headquarters is actually in Houston, and that's where they have the majority of the team.
Mm-hmm. Oh, okay.
Yeah, I think about 10 people over there.
Mm-hmm. Yeah, I see more and more this BDC managers gonna participate and show, and this is also the company I think you should show your cutting edge technologies and their skill, which I think is great. I think this is the way to go. Anyone has any question? Yes, yesterday, yeah, I visit architectural department, A561 class. You know, they are working on the Roosevelt Islands project.
Yeah, fine.
Currently is for Freedom Library, not gallery. So they're working on it. I gave them a general structural ideas. So chapter 1, like structural 101. I think they are currently working on structural system programming, and yeah, this is the second month. So then try to guide them that what the structural system should be, because I'm sure they're gonna come up with many interesting building and geometry. And one thing actually I currently learning, try to practice is Rhino in Rhino grasshopper plus in the Revit, inside the Revit. Oh, so here's one question for
Rhino
you.
inside Revit, right?
Yeah, Rhino inside Revit. So here's the things. You're not architect. You're practicing in the construction company. So how did you start your BIM digital twin model? Like some project architect team, right? Designer teams, they choose like a Revit, and they entirely deliver this all to the models to the owner, and obviously you took it over, or you're gonna start from the scratch?
Yeah. So that's what we do. We have the architectural Revit file coming in and the structure Revit file coming in. So we kind of make a new Revit file and link both of those in. And that linked file, we send it to all the subcontractors. So like the electrical or duct, the fire guy, we send it to them. And we do most of our work on Naviswork, which is NWC files. So everyone is expected to produce an NWC file, and that's what we have it on our contract. That's like the Naviswork file. But some companies use Revisto also. That's like another one. Revisto and Procore are like the other software that are also being used. But yeah, we kind of take the model from structure and architecture and send it over to the team on the field and to all the subcontractors.
Yeah, things for Halo Tower, I know recently it's top up. So I went there the day before. So I just visit because they had some flag raising ceremony. And because the building has a curved geometry, so edge slab edge was a little kind of challenging because every floor is different. And contractor really figured out, but obviously there will be some difference between the edge slab and facade, which is about connections. The couple of inch offs locally. So, they're always has the issue and challenging. And physical model versus virtual model versus physical words, there is always because
there's always a margin of error that everyone uses.
Yeah. So also the cotton wall, is because the structural slab initially it proposed like a circular and a curved versus the final cotton wall, it was segmented, right? So I know the real words, the designer wants to have a smooth curve shape versus, but the reality is in how to build, it's really so expensive and it's hard to do that. So they changed it and during the CA and make a segmented cotton wall. But anyway, it looks good. I think it's sooner or later, or the cotton wall will be finished by end of the March. So I think this is, I'll send you the couple of photo. I already posted this photo you already saw, right? So this is gonna be a one. Okay. Any questions? Students? I'm gonna choose one. Everybody's sleeping? Let me see. Okay, Tom, are you there? Thomas.
Yep.
All right, you guys actually, Thomas is also very interested in technology. He showed me that he used a Fusion, Autodesk Fusion, and he built some digital fabricated, what is a vase? Is that, oh, no, the pineapple.
Yeah.
So do you have any question? I think this is technology roulette is, we actually build a structural club. Because of today we are supposed to visit the makerspace to do something, and because I needed some teaching standing table, but today we have a heavy snow, so we just push it to the next week. But Thomas I think he has something we're also interested in fabrication. Do you have any question?
I mean, like it's not our first time hearing about BIM, so like it was pretty straightforward. We actually had to do a BIM presentation in the class where we learned Revit, so we had to do a presentation learning all about BIM.
So what I try to now, our final project, like why don't we, because yeah, and you're gonna build a 3D model, right? We're gonna end up with a DXF file. We're gonna bring this DXF file to the Revit, and we can make this nice, also presentable the sketch. I think Rhino, especially Rhino inside Revit, I've been using it. Oh wow, okay, this is I like to use it more and more because there are a couple of features I actually did manually setting up the elevation, like a 100-story building. I actually copy or replicate, kind of many times. But now it seems like the Rhino or the Rabbit inside the Rhino inside the Rabbit has all the commands. So I was looking at this.
Bring the model and
Wow.
make the changes.
Yeah. So, I mean, I think I'm dealing with many complex geometry here and there, but wow, because is this really helpful? So no matter what, a structure engineer should have some capability of handling this complex geometry to help your architect designers with the structural form. So basically, they're using Rhino, especially a lot as during the design phase or SketchUp, but I more prefer at this point Rhino because we know only Rhino a little bit. So I'm enjoying a little bit a lot, but yes, something we need to know how to communicate with. So this is something that too, same language, how we can communicate together. Also later on is a business, right? In order to win the project, you need to kind of show your capabilities. It's because Rhino is every designers use it. So I encourage you to let's pay attention. If you're in the building industry, if you really wants to stay in this building structural engineering, yes, I really strongly recommend. I think this to me is a must to learn. All right, Deb, are you planning to visit someday, or are you gonna have you talked with the architectural department, any professor for your same presentation?
Not yet.
Not
I'm
yet.
not sure where I'm visiting. So once I decide date, then I'll probably reach out to another professor.
Yeah. Okay. Sounds good.
Thank you so much, Simon.
All right, thank you, Deb. I actually recorded. I will share with my all student and especially probably with other architecture student as well. I'm visiting next Monday. So this is kind of great material. I try to encourage them and challenge them to learn more.
Yeah.
Okay.
Yeah.
Sounds
Thank you
great.
so much.
Thank you, Dave. I appreciate this. Okay. Hello. We're gonna have a take a 10-minute break. You guys see here?
Yes,
there. Okay. So you guys actually did the shoveling today?
Yep.
All right. Hold on a second. So let's guess come back to 11 maybe 35. 11:35. We're gonna have the now moving to the flow framing session. Since we need to we are just starting learning flow framing and also using ETABS. I want you guys actually all the teams to bring your building layout first. So I know this week today is I'm gonna give you the brief structural flow framing. It's just idea, and then the next week I think so we're gonna start working on your project for building flow layout. So today is very important. So we're gonna have second session at 11:35. Cool. Okay. So let's come back 11:35. Oh, okay. Share the screen again. Okay. So you see my PowerPoint, right?
Yeah,
so yeah. So again, that we need to figure out what is the base. How we're gonna start lay out the columns and walls, which is gravity vertical elements to support our whole entire building weight floors, right? So something that we need to understand that our practice and also designers or tenants, I think this based upon all history. You already feel that space inside the house, office, school. You already kind of before you in probably not quite deeply aware of it, but you already feel it. Oh, this space is pretty large. This space is so tight, too small. Yeah, those are all connected. The our end users, right? Probably psychologically also for productive productive just space use, all those are factor in current column grid layout was somehow established. So that I like to discuss in general current the grid layout practice. So we're going to talk about the column layout and first to set up our grid line. I think ETAPS you practice a little bit that I explain better set up the grid. If your building is pretty regular, rectangular or square, something relatively regular shape, then it's much easier to set it up to grid line so that you could um, create your 3D structural geometry by using the grid system. After grid system is established, we usually start place the vertical elements, column and wall, right? Columns and walls. You practice it. We had some ETAPS 101 section. We set up the grid line and draw the column. Basically, you drop the column on the plan view, mostly similar to Revit. You drop the column. If you think you have a column in the grid intersection point, yes, easier to drop the column at the intersection point. So you define once you define all gravity, the elements, vertical elements with the grid, you better start to draw, lay out the beam and girder. Which first thing is you need to provide the beams to tie the columns, right? Columns, the walls, because the vertical elements we discussed is going to be a 40-story building. So at each floor level, we need to tie the columns to brace the column, which we're going to talk about it. I'm sure you guys already learned the unblazed lengths, which is we're going to talk briefly later. And yeah, so with that all the floor framing layout, we need to know how ETAPS really the kind of play that then some users needs to assign all the slab as a metal deck and concrete slab, and then orientation of a slab, and assigning the loading on the slab, which is our design load, gravity dead load, and superimposed dead load and live load. With all design loads and also boundary conditions, and we should be able to analyze the 3D framing and calculate the shear force and moment, something like that. So we're gonna get into that later. I think I want you to just remind, so bring it up your previous practice, the cantilever column wall is pretty much the same procedure. We're gonna define geometry, boundary condition, define the load, assign the load, analyze the model, calculate the member forces, shear bending, and checking the deflection. I think we are following the same procedure. So we Super. All right, sorry about that. So let's move on. I think it's a basic, some information we need to understand. Next page. Because the office building we are designing, we need to understand what is typical layout and column spacing, right? Also beam span. Basically, it depends on your project building layout, how big that is. I didn't give you the overall size, but we maybe just, I expect you guys to do some benchmark and come up with some existing building so that you could maybe practice, you could draw the column layout more reasonably. So I'm gonna give you the just general rule of practice. The column spacing for the commercial, we typically use a 30 feet, right? 30 feet spacing. I will show you on the next page on the plan. And typically, yes, it depends on, again, the space use. Since we are designing commercial office building, then column spacing is typical 30 feet. Let's move on to this. So here you could see that one of the example architectural interior layout. I drew the red dots dash line representing the column grid. Because it depends on the building overall footprints, but slightly it should be adjusted. But you could see that major column, right, on plan north. Let me just annotate. Yep. So this is column spacing. I'm talking about column spacing, typically 30 feet. And typical, see? So there are a couple of reasons, because architecturally, they usually prefer to have kind of uniform spacing, column spacing layout, so that their exterior outlook, right, the curtain wall, we call enclosure wall, also is well fit within 30-feet module. Also, knowing the interior office space module, you see that there are module, cubicle, or interior office room. Their office room layout, I think a 15-feet module is pretty well fit, right? So this is one of the example, the office layout. I think it's pretty old, even though old building or built, existing building, but it gave us some idea of uniform column spacing. But at the end, obviously building footprint is not as big, so that they kind of introduce another grid at the end of the buildings. Also, as you notice that the building footprint at the corner, there is some recessed slab, which is part of architectural design intention. So you could see the first about uniform column along the perimeter on north side and south side, but west and east side, you have some column spacing, but because of the corner offset, I think instead of having the column at the corner, they offset the column and make the uniform column spacing on west side and east side. So there are many factors. Usually we need to consider and coordinate with the design architect team based upon their interior use or exterior outlook and all the exterior curtain wall module. And there are many factors, but basically high-rise super tall building, what you can guess from this plan, there is no such an interior column. I'm saying intermediate column inside here, right? No interior column, typically here on major workplace. The reason why is if we happen to have the intermediate column, which might be a good for structural, but like we're losing the flexibility of this all in the office space. That if assume that you are the building owner, you need to list, right? Rent each floor basis, or bay by bay, right? Or some tenants might using some double bay, triple bay. But if you have the interior column, right, it may be interfere with their office layout. So typical high-rise building expertise, designer and engineer, we usually avoid an intermediate column in this open office space. Okay, and second, what we need to consider here, because this building layout is include every aspect of really planning. But one you can see is this hatch area in the center, right? I just hatch it because we need some structural backbone. I mean, part of lateral system. Because the building, in order to operate, serve, or do their function, we need elevators or stairs, right? Maybe I can turn up this guy. Okay, maybe I cannot turn up this is one images. So let me zoom in a little bit. This is very important because this is not engineering planning, but this eventually explain all aspect of high-rise building design. You need to understand so that you are the structural and high-rise expert. So going back to this hatch area, I call people, maybe people, designer and structural engineer, we often use the core zone. It's a core, means central essential area, right? Serving for your essential function. So those areas include stairs, series of elevators, right? Or bathrooms, restrooms, and some electrical rooms, or here's another flat elevator. So passenger elevators, number of passenger elevators, or flat elevators, or stairs on each end. So what you can guess, oh, we have 2 stairs, right? 2 stairs. Again, 2 stairs. That's a requirement. If you are in any high-rise building, you should always fully aware of 2 egress stairs. Typically, they're spread apart in order to cover all evacuation situations. So I think there is something requirements, maximum egress safety evacuation distance, right? So at the farthest and corner office, you should be evacuate to access to stairs within some distance. So if you have a building has a footprint, obviously architect should really figure out what will be the maximum distance requirements and place the stairs at that right location to meet this egress safety evacuation requirement. So because the building is, if this building is much bigger, obviously you need more. But typically high-rise building, because you're limited in your site area, and there is total gross floor area requirement, and owners wants to maybe it's tall building. There are many factors, data, you need to meet it. I think you end up with some decent size of big floor plate, which usually cover by 2 elevator is probably in typical condition case. But you maybe see that some other stairs, right? It's right here, this building has another stairs. This might be the interfloor stairs. So if, let's say Google or Apple, oh, you know what? I only need, I like to list 3 floors, 2 floors, right? Because these companies want to fully occupy 2 floors, but they prefer to have a communication stairs into floors. So most that cases, the tenant's requirements and the owner are really allowed to install kind of interfloor stairs so that you may see some stairs locally, which only serve 2 floors, right? So, but that is something more tenants related issue, but structural, entire overall fire or something that extends evacuation purpose, we must have 2 egress stairs. So pay attention, your final project, you need to somehow address 2 egress stairs or a number of elevators. So that is very essential item you need to address as well. So those are all right, essential elements located in the middle backbone zone, let's say core, right? And we typically engineer use either steel frame or concrete frame, which is concrete show wall or steel brace frame. 30, 40-story building, maybe in 20, 30 years ago in New York City, they use a steel or the framing given for lateral system, but that is extremely expensive now, and more structural engineering and architect and constructions actually in the market, we prefer to use a concrete show wall as a backbone so that this wall will work like load carrying elements to support your flow load. So it's part of your, like a wall, taking care of gravity load, and also part of a lateral system to provide resistance against the wind and seismic load. So obviously, let me zoom out. This layout explains everything. What you're gonna do in your final project, you need to come up with geometry, footprints, right? Building floor layout. I think geometry, you guys actually discussed. I don't want to give it too much actually restriction. So building, if you choose a site, yes, you come up with a floor plate dimension. Could be square or rectangular or circular, but obviously rectangular or square is relatively easy to create the geometry. But column layout, you need to discuss among your team. Initially, place the column based upon with your column grid, right? So the one thing I'd like to add here is now you probably now understand that, okay, one dimension, we have a 30 feet column grid spacing, but how about the other short direction? Yes, that's another, but because of this high-rise building, in this case, we have a central core, right? Somehow the span between core wall, which is shore wall, concrete wall, to our exterior column, which typically office space, office building, we commonly see 40 to 45 feet span. And that is pretty these days common. And when you closely look at it here as architectural background, because office is space, workspace is mostly placed outside, away from the core, so that you have a corridor is wrapping around the concrete core wall, right? This is something I don't like it somehow. But usually you see the corridor circulating around your concrete core wall, which means you need to you should be able to travel between, one side of the building to the other side of the building. So typically this is kind of circulation, right? We kind of set internally by placing all the office space outside. Next time, if you are you become something like the Elon Musk, and if you happen to have a corner office, right? This corner office. Now this building probably, I don't know what kind of building I took it from, but they just placed the conference room at the corner. You see that conference room, right? And office managers placed along each building side. Typically, these days, this is pretty common practice. They put the conference more multifunctional purposes, first priorities, but you just say the corporate corner office is usually placed at the corner. So, all right, just send me your successful story when you eventually land on the corner office. All right, any question? This is very important. Here, you need to really take a closely look at it. Each team next week, you should bring floor plan layout, showing the column, right? Grid, and then central core, laterals, part of lateral system core, series of concrete wall. I'll maybe explain a little bit more later. But first of all, you can just practice and lay out, set the grid, and place the column. So once your team is ready, you can just start working on the ETABS, right? Setting the grid, and then place the column. All right. Now this is very typical standardized. One thing that I just said, because this is building architecture plane, the corner slab is offset. So instead of having the one corner column, they put the two column on one column each side. So try to make the corner view, open core view. So this is something that additional architectural design intents, maybe owner's request. If you're owner and CEO of your the building, some people may have their own preference. You know what? I like my office at the corner, but I don't want column to block me. So I want to open corner view. Then the structural purpose and architectural purpose, and there are many different purpose. Yes, we may have to arrange our column layout based upon that. Okay, now second. Some background. Okay, not much extra background, but here this layout. Okay, building has a central concrete core layout, but again, two egress stairs must, right? But number of elevators, right? Passenger and flight elevators is to be based upon your own vertical circulation requirement. This is it's not ours. Usually architect, and they discuss with a vertical transportation analysis specialist. They just decide how many elevators they do need it to serve the building. Obviously, the taller building, right, need more elevators. Sometimes these elevators can have a joining, and they program it so that some elevator only serve lower floor, some elevator goes to middle, some of them is going only serve the high floors. So I think this is something vertical transportation. The reason why is you don't want 1 minute to get your office, right? So basically, this is something that for their vertical transportation. How many seconds do you usually have to wait, right? How many minutes usually does it take to get to your office? This is important. So they need to really study based upon all our human psychological kind of factor, how people actually kind of patient to wait their elevator. I think those are also one of the key elements. So that they have to decide enough number of elevators. It's part of vertical transportation system study. And here, slightly different because of building layout. Architect, I want something unique, right? They just make a notch at each left and right. Oh, what is this? But, based upon this floor plate, we need to start lay out the column. Initially, you could just draw the grid line, and the basic 101 is column should be placed along the facade, right? Let me just go back to here. This column is placed along the facade, just close to the edge of slab, right? Now, how about this one? This layout, you see some column is placed in the intermediates away from the facade. What's going on? Yes, I think this is pretty old style, more specifically maybe owner, or there's some reason. There are many, probably I can guess some reason. First, some people, they prefer to not to have a column, so make all the column-free space here, right? They just rather have an intermediate column, even though this is interfere with your interior layout. But some owner or someone, they either just try to make this open view. So this is something kind of example, not structural first top solutions, but because of there's a couple of reasons, they place the column, which create kind of cantilever. So this is something that impact. Since someone actually personally prefer, hey Simon, I want column free space along so can we move this column, push almost 10, 13 feet inbound. Yes, I mean, structurally, we can make it work, right? Here, but you need to explain. You need also have our responsibility is we need to educate the client, right? We are the specialist, client is not. They have their personal perception, preference, but this is structural cost impact and also architectural leasing obstacle, right? Is something they need to factor in to make a final decision. So, I'm a structural engineer as for the high-rise building. It's not only just the kind of calculation engineering. We should be able to guide them properly. So the building should be kind of built more structurally efficient and cost effectively, right? Try to avoid any non-necessary waste. Also, eventually, is gonna impact on your office layout, office list, and it's gonna probably market value gonna definitely goes down. Maybe at the time people maybe love it, but later people doesn't like it because you know what, this column is interfere with my office layout. Always, wait a minute, who designed this building, right? They're gonna ask. They don't have any background history. They don't know why designer really placed the column inbound. Yeah, they just ask, right? That means, right? Some people don't know the history. They just may have a bias kind of opinion on the main designer and engineer. Actually, who's the architect would, right? Design or let this column is inbound and which is not space is efficient. So, I mean, just we need to think about what is best practice relatively, right? Proper practice to serve and also try to maximize your create the revenue while you're investing on your new office building construction and design and construction. So this is a general approach, right? Before you jump on an engineering layout, column. Okay, we are not just engineering kind of the building. We need to also bring this more psychological, market-driven, value-oriented. We need to provide those great solution. Okay, here's another similar, but okay, well, you could see some very similar, right? Stairs, elevator bank, right? Number of elevators, 3 elevators side by side, obviously keep this overall wall length width, roughly 10, 10, 10, or 9, 9, 9, so about 20 to 30 feet the width of the wall, but length obviously depends on overall building footprints to have enough space to serve. But you see that 2 elevators, right? Stairs, 2 stairs. Again, important. If you don't address it, you prove it you are not high-rise building specialist. So very important. So the column layout is similar because of slab layout, right? Here is also offset. So we need to place the column along the edge of slab to support, obviously support the slab. But now question is, how about this? Hey, wait a minute. There is something, what dimension? It's about 10 feet. There is something cantilever portions. Some architect and owner wants to, but now question is, where is the right column location? You want to put the column recommended here at the corner, push here, or just keep it placed as you see, right? And make a cantilever. This is something engineering judgments, and you need also collectively you need to discuss with your owners and architect, but also you need so that we can determine where is the column location is most work both structurally and architecturally. So this one, because I'm looking at the span length from here to here, right? Maybe 30, 40 feet. If we push this one another 10 feet outside, make the span is much longer, 40 feet, which I think relatively to long span might be the end up with a big beam depth, big beam. Also, maybe architecturally they prefer to column inbound and make this cantilever space. I think so. This example seems like it's a collective idea as they end up with this column layout. All right, one more similar, 2 stairs, elevators, right? But building has a curved for lower plate, but the columns are all placed along the exterior face. But you need to always keep an eye on that. This is span, column to wall, vertical support, support of, and those span lengths. Typically, OPs, we prefer 40 to 45 feet. Maybe some cases, old days, Sears Tower and John Hancock, they might have something long span because old days, at the time they're using floor truss, not double wide French beams. But I'm talking about in general current practice in high-rise building, we can't mostly use wide flange beam, even W16, W18, W21, 24. Other might be a little bit deeper, but we need to really factor in and size all the member to define optimal floor-to-floor height. So I think the things, the structural, at this point, what we are talking about is mostly a structural planning. The planning, including structural, it is structural input, architectural, all the layout input, owners' requirements, all this have to be factored in, and we are finally decide the final column layout. Okay, so far I explained in general. I want you guys to actually take a look at it and don't miss it something. This is most important. The next one is something we can move next step to discuss more structural and engineering aspect. Before we move on, yesterday I invite all of you, but no chance. But I gave some structural 101 to the architectural students. I think they're currently working on Roosevelt Island 4 Freedom libraries. And I try to explain a brief structural, wait a minute, this color change. So probably this is actually good for you too. So let me just briefly show. I think it's obviously information itself is pretty much identical, but different type of structure. But what you have to aware is I can explain here with the example that I gave architecture student yesterday. So here, similar column spacing, column, right? Grids, number and alphabet. I think this one I lay out 30 feet. So this is not high-rise building, but I just made it for kind of introduction purpose. So column spacing 30 feet on set. What you're looking at is a foundation system. Our foundation system is much heavier, but this is low rise. I'll just explain. But you're already familiar with foundation wall. Wall need a footing, wall footing. A column, I think is sitting on the wall, so we need a concrete pier, right? Also 2 stairs. I assume this is will be made out of concrete wall. And the elevator shaft wall, I made this one as shaft concrete show wall. So typical interior steel column, right, is sitting on the shallow foundation footing. I show dashed line, that's the footing. And you see the steel I-shaped column here. But the exterior column, because of the exterior column is conflict, they are sitting on the wall. So we usually don't bring the steel column all the way down to the basement level. Instead, we build the concrete pier so that steel column will sit on top of this pier at the first floor. So just looking at just an overall system, even though this is relatively small, you'll see that we need a foundation, mat foundation, right, for your entire tower or partially the wall, right? And you need to handle this also individual column, footing, or our case is most likely entire mat because different level of height and overall weight. So we need using a slightly different approach, but ideal concept is same. We need to set our building on basements or foundation on the foundation system, which could be shallow foundation, the foundation. We normally you guys learn spread frame or mat, so that should be placed on the bottom of the structure. Here, change that. Maybe so, maybe too big. The first floor, since we have a foundation walls is coming up at the stop at the first floor. See the pier, your dash line, and the steel column is starting at the first floor, right? So this is pretty much normal case. The mid-rise building, or it could be done also in the high-rise building, but this is and kind of one of solutions. And what you can see here, floor frame layout, which is similar to what you design. Concrete core wall, you see that too, concrete core wall. I think I meant to be, this is stair shaft wall and elevator shaft wall here, right? Work like a vertical wall support, so supporting the beam, to support the slab. So beam is a flaming into the wall, right? So the wall is going to support your gravity load. And also girder is obviously a beam. And if we don't have any wall, obviously those areas should be supported by the column and the girder, which is are tying the columns. And also the beams in the middle bay, we call filler beam, should be placed such uniformly, mostly typical cases. But the spacing of the beam, typically we use 10 feet. But 10 feet means it's not absolute number. It's because of the metal decks and concrete slab above, based upon their capacity, we are able to choose those beam spacing. But typical, I give you the 30 feet column spacing, right? I think it's end up with a great 10 feet uniform spacing of the beam. So this is very common practice. If you end up with a 10 feet spacing of the column, I think you're gonna end up with the two beams, 10 feet spacing, okay? So you need to follow 10 feet because sometimes maybe a student actually drew too many beams, which is not necessary. Also, the reason why I highlighted 10 feet is because I want you guys to use your project as part of portfolio. I wanted to show and your project follow general practice, so that give you the general understanding, prove your understanding of high-rise building design. Now, today's second topic is, okay, beam framing, I don't see any issue, right? Looks pretty straightforward. Do you see any complexity based upon obviously you're building floor plates. But now, how about the metal deck slab? Yes, metal deck. It's collocated. It's most likely one-way span. So that metal deck is sitting on beams, right? Because collocated is folded structure. So metal deck should be sit on multiple beams so that they are supported. After that, the concrete will be poured on the top of the metal deck. Metal deck is a structural element, like a rebar is in the concrete beam or concrete slab. Okay, metal deck is a structural deck. So it takes the tension forces. So typically here, I'll give you here, things I want, you guys also use either two slab system. One is a 3-inch metal deck, which is 3-inch makes sense, is usually support the concrete weight and live load, floor live load over your slab span, which is 10 feet, right? So structurally, 3 inches is pretty common for 10 feet office loading conditions, but sometimes 2 inches also used more short span for less loading. But I'm gonna recommend you guys use 3-inch metal deck plus 3.25-inch lightweight concrete slab. Or I'll just give you another option. Your slab system should be 3-inch metal deck plus 4-inch, 4.5-inch normal weight concrete. Same metal deck, typically, I'll add more gauge. Thickness 18 or 20, but I recommend to use 18 gauge. Part of, I don't know, they come up with the gauge, part of the metal deck thickness. The lower number, gauge 18, 16, 14 is thicker than gauge 20, 22. I don't know why they just came up with that system opposite way, but I want you to choose one or the other. First option, option one is a lightweight concrete slab, or if you're using normal weight concrete, you have to follow this. I will explain that later. Obviously, you know that what is the weight difference? Lightweight concrete versus normal weight concrete, right? So high-rise construction, we try to use lightweight concrete instead of normal weight concrete because of weight difference. We should be able to calculate the uniform weight of slab. I think I explained last week, but we'll maybe exercise tomorrow or next week again. So this is the first floor layout, right? I think second floor is pretty much similar. I'm gonna skip. And now section, I make this as a rabbit structure for their presentation or architectural student to guide them. But I think you could see that the foundations and their interactions, the steel column is sitting on the concrete pier, right? At the grid line. But this one's, obviously, you'll see that metal deck slab is parallel to your wall. So there will be some kind of section slightly different between these two at the column grid or off grid. All right, so what we are focusing now, we're about to design the floor framing, beam size, and first of all, layout of column grid, set all your floor framing geometry, and we need to define the floor design load so that we should be able to design the floor framing. But it's not just pure steel. The reason here is the one thing, composite floor framing, we need to understand. We're going to study a little bit. So you are designing the composite floor framing, composite beams. I think likely undergraduate steel course didn't probably touch the composite floor framing. Instead, you learn only steel beam and steel column design. Anybody actually remember that you learn composite beam in steel class? No? Probably not, but anyway, we need to use composite floor framing. So here is just some most important ceiling sandwich study. I think I showed you before. What we're handling is while we're defining all the layout and spacing and loading and all this, eventually what we're dealing with, we are designing, right? Very important aspect so that we are defining from here to here. What we said, 3-inch metal deck, let's say 3¼ inch live weight concrete is 6.25 inches. Okay, now when we designed this beam, but this is gonna be a composite beams, so we're gonna talk about it later. So we are defining beam size. Maybe we end up with a W16 or a W18, right? This is kind of typical beam size. I think I'm more expecting W18 for 40 to 45 feet span length. And Goddard obviously should be deeper, so that connection will look like this. Now, so this is our main role. We need to define this is ceiling sandwich structural elements as much as possible tightly. Now, underneath, obviously fireproofing, right? You need to protect all the steel for fire. And obviously the MEP needed some space for their duct. And then architecturally, if you are prepared to cover it up, obviously office, class A office, they have a ceiling and a light fixture should be placed, they need some space. And then the owner has their ceiling height requirements, right? Obviously, this is, you guys actually design the office building. Let's say class A office. Class A means I think they need to have a very high ceiling height, part of your leasing price, the value. So owner wants to always achieve the highest ceiling. That means this ceiling sandwich studies should be really thoroughly take care of and try to meet the owner's ceiling height requirement, right? So the reason why this is a very important thing is if you save somehow 1 inch multiplied by your number of floor, 40, so 40 inches saving. It's not only structural material saving, obviously all cotton wall and all plumbing, everything is really adding up. And so that since high-rise building, we're dealing with multiple floors, so difficult floor framing system study is very crucial. So I want you to aware of this. Now, Dev, your colleagues, architectural students, showed a lot of beam related the information model, right? Then he need to take care of, set the first priority for structural element first, and showed a lot of ducts and piping, plumbing, and electric conduit should be happening within here, above the ceiling. right? Luckily, we don't deal with a very small piece element. So I think, to me, I think structurally a little better shape than just all plumbing and electric. They are too tiny, but they always try to figure out how to route it, try to avoid it, conflict within this ceiling. But surprisingly, you'll see a lot of things above the ceiling. If you are interested, why don't you check your uh, home or attic, right? Or maybe office, if you have an office, and just take a look at it. You'll see a lot of stuff above the ceiling. So that's very important. What this guy means, actually, structural piece is absolutely essential element. But in order to make buildings operable, yeah, this is all the vein and fresh. This has to give us some function works, right? So this is, I think, is typically architect, structural engineer, MEP engineers, the main three parties, really kind of working closely together during the design phase. But especially high-rise building, further high priorities is architect and structural. So typically, when project is kicked off, the architect usually contact structural engineer first and discuss their project requirement. Later on, they could hire the mechanical engineering, electrical engineering, plumbing engineers. All right. So I explained very fundamental floor framing system and importance and our role, right? And this is cool. This is right. So you're the big, one influencer. So I want you to just be, feel proud of self, and we're gonna uh, move on to next. But similar to the office composite steel pro framing, I think. Let me clean up. Erase. Okay. Okay. Yeah, concrete building is more straightforward. Typically residential. Residential buildings, I show beam, but typically, it's a flat plate slab. It's pretty common, no beams. So because also their ceiling height limitation is requirement is relatively lower than office because your space, right, is smaller than office. So your ceiling requirement is slightly lower. But obviously, the structural system for residential building, we commonly mostly use concrete. So do not mention about, I designed a concrete building for your office building. It's a wrong statement, right? Because at least I want you to understand basic of basic. In United States construction industry, concrete mostly residential, steel for commercial. But some Middle East or other Africa or southern third country, if they don't have a steel infrastructure, most likely they're using concrete for even office. But since we are practicing in United States, I think I want you to at least fully aware of steel office building. So here's just diagram a little bit. So now, since we are reaching to 1 o'clock, let's see graphically. Is this straightforward? This is kind of clear enough? So what we're doing is, metal deck is spanning perpendicular on the beams, right? So it's creating some foam, right? They install the shear stud, right? You see there's some stud. Stud, right? This is something I could see that we need some glue. We call it shear stud. It's a glue between steel and concrete slab. We need to tie together, right? Because it is a composite floor framing, so that steel and concrete should be tied together. So you're probably already aware of it. I will explain with some simple beam. We are talking about T-beam. Since slab and the beam is tied together, even though, let's say, concrete beam, slab and steel beam even glued together with the shear stud, work like a T-beam, which must much stiffer, which means we can optimize the steel shape. It's mostly structure because of structural efficiency and stronger, so that we can save more steel. So look at this kind of diagram closely. This is straightforward, right? After shear stud installation, you put the wire mesh. It's part of rebar, small wire, small side, because we need to make sure the concrete is cracking is minimized. So because concrete always crack based upon temperature change, right? We call prevent shrinkage reinforcement. So we put usually place the wire mesh, or sometimes few locally number 4 rebars locally to somehow reinforce on certain the kind of crack preventions. So what you could see now is something the composite floor framing floor, but high-rise building, we are usually end up with a relatively short span, 40, 45 feet, right? But when we designing convention center or atrium, Javits Center, I may have to go tomorrow, but today is, I feel bad. The New York builds, I think, I'm not sure, as today's people can go there, but like a long span structure, right? Long span roof. Obviously, we don't use concrete, only metal deck with some floor finish, right? Roof finish. It should be make a light. We need to use a light material. So kind of long span structure, they're using truss and metal deck as a part of steel structure. As opposed to building, because we need a solid, because we have a heavy light load when a solid base, so metal deck with the wire mesh and concrete is pretty common. So this is part of composite slab profile. The image on the lab is I just try to at least point out one for the long span structure with only metal deck. This metal deck is a structural deck, so they can handle some relatively light architectural waterproofing and material above. So just try to wrap up today, but I'm gonna send you the email that next week as kind of homework. So each team should bring absolutely your building flow layout, either sketch or ETABS you guys actually discussed, right? Came up with your flow layout. If you can show the column, perfect. Show the wall, perfect. This is perfect time. We need to kind of exercise. This is fun, right? I don't want to give every single one because I want you to enjoy the freedom. You are a designer. So just few slides I'm gonna flip over. So this is another architect, came up with something interesting geometry they want to kind of design. So I gave them, what about, since you have a long cantilever, right, multiple floor, why don't we use something diagonal or column system? So this is something sitting on deep foundation on wall foundation and foundation wall with a concrete pier, but the column is sit on the concrete at the base and erected above as go up. And as you are aware, you already learned steel connection. I'm sure you probably learned steel in steel class, teach it, steel connection, bolted connection, welded connection. I'm sure we're gonna discuss it. We have a nice AISC donated steel structure sculpture in front of maybe architectural department. I think we need to, maybe we're gonna visit there and see what all the type of steel framing connection looks like. So, all right, so this is already 12:50. I'm gonna just kind of send you that this PowerPoint maybe next week when you guys bring all your floor plan, and then we're gonna discuss a little bit of additional just the construction of composite floor framing design and example, and some additional reference, the composite metal deck, fire rating requirements, and some camber and shear stud. We're gonna touch on that in the first session, and then we're gonna spend more time to work on composite floor framing design. So I'm sure everybody should bring, a team should bring your building floor plan layout. And this is the video I sent you. I'm gonna resend you. Watch out. Just watch this tutorial. You need to develop your knowledge, learning skill set using all different material. So this is ETAP's composite floor framing tutorial. I want you to watch maybe 1 or 2 times so that we're gonna obviously practice and move faster, because this is basic kind of procedure composite floor framing design. All right. I know this is kind of awkward. I don't like online class, but this is what it is. I'm gonna go out to clean up my old snow again. But I hope you guys enjoy shoveling snow, and see you next week. And next couple of weeks is very important. I'm gonna also we're gonna set find a middle term presentation to all the teams to get involved and practice, and then about the practice about your current project progress on floor framing design. So I'm gonna set the date and discuss with you probably maybe within 2-3 weeks. I think we need to have middle term presentations. All right.